Hello everyone. Today I'm going to give my project review on my Capstone project 6, that is unsupervised ML, based on the topic of Netflix movies and TV shows clustering. This is a unsupervised model, and this is my project summary. In the dataset that I have got, there are around 7,787 titles and 12 features, which are 12 columns, and these are few of those columns. And let's not deep dive into the project summary so that I can explain more in the uh, process. And coming to the problem statement, I wanted to show about the same title that I've told you. It is Netflix movies and TV shows clustering. And yeah, coming to know my data, I've imported libraries. Those are standard libraries: pandas, numpy, matplotlib, seaborn, and I imported warnings also to filter all the warnings and display my output in a neat and clean manner. And for machine learning algorithms and processes, I've used sklearn pre-processing, and I've used many of the other classification reports and for accuracy scores also. And I've loaded the dataset, and I've also copied the dataset for another time to perform all the other operations in part 2 of this uh, process. Okay, and this is my dataset head, which are the top 5 rows, to just show the first look of my dataset. And as I've told you, I've got an 7,787 rows and 12 columns. And coming to the information of the dataset, there are 12 rows, with most of them are object data type, and one is integer data type, and that is release year. And to find any duplicated values, I didn't find any duplicated values, but yes, I have found rows that have null values, and most of them come from director column, cast column, country, and data added, and rating. And I wanted to show the mean of my null values, because whether to impute the data set with the mean, or to fill, or fill that with the median or mode, or to delete the data set if that is not making any sense for data analysis, I wanted to show the mean. This is visualization of my null hypothesis, null visualizations. This is what I've wrote there also. These are all the columns that I have. And to describe all the columns, this is how to describe them with the release year, and I'm including all, because if I don't include all, it shows only object data type as default, or integer data type as default. I didn't want that. I want every column to be shown. And these are all the variables and in the my data set. And I wanted to check if there are any unique values, or if there are any repeatables. Few columns have unique values, and most of them have very few number of repeated columns. And in data wrangling, as I've told you that I found null values. I wanted to fill those null values as according to their mean numbers. I filled the director column with unknown values, which has a 31% of data that is missing. Uh, and in cast column, there are around 9% of missing data, and I wanted to fill that with not available. In Also in country, I filled that with unknown, because I didn't wanted to fill that with fill, rather than giving previous values and later values to uh, uh, not have accurate, not reduce the accuracy. I didn't want to do that. There is around 6.5% missing data in that. And filled data added and rating columns with using fill, because there are around very small number of percentage that is missing around. As you can see, that is data is only 0.1%, and rating is 0.08%. Those are very few values, so I've used fill to fill those remaining values. And I've converted data added column data type to date time. And I have also created few separate columns to perform analysis. From the date added column only, I've created year, month, and month name, and date added. for columns for analysis. And I've also extracted number unit from duration, and also whether that is for duration value is for whether there is seasons or whether it is a time, because two of the values in the duration are intermixed with each other. And also I have expanded columns for listed in, and created a decade column to analysis on which decade the movie or the show type is released. And I've standardized the categories of director and country, removing all extra spaces from the column. And I've also shown how much old the content is when added to the Netflix, because that in the recent times, as OTT is increased, if we can say that the movie is releasing in 2025 and added into Netflix in 2026. But there is also few older content in Netflix that is from year 1970s or 1980s. I wanted to show the age gap of the year added and the release year as well, and also to show the multi-genre, because not all the movies are shot in a single genre, or so they have multiple genre like rom-com or suspense and crime, like that. And the frequency of directors as well, to show what is the frequency of directors shooting the movies. So this is the first data set after creating all those values, all the other data types and all the other values that I've created also. So after that, I'm getting 22 columns. Like I've created around 8 to 9 other columns as well. After that, I've also filled the null values. So I wanted to see again whether if there is any column that is left over. So as you can see that everything is showing 0.0. There is no null value present in the data set as of now. So the data is completely filled. And yeah, I've downloaded that to upload in my data set. These are all the manipulations that I have done. And to visualize, my first chart is obviously whether to show what type of content that is, whether that is a TV show or a movie. Mm. And my second chart comes to show the top 10 production countries. As we can see that the most movies produced are from US, and second comes India, and so on. And this is the content added into the Netflix over years. Uh, as you can see, started from 2008 to 2020. There is a significant rise from 2016 to 2019, I guess, 19. There is a significant spike in adding movies into the OTT platforms and Netflix. And the next chart comes with the content ratings, and the top content rating is for TVMA, and least content is for NC-17. There are around more than 2000, close to 2800 or 900 for TVMA, and close to zero for NC-17. And next chart comes the type of content that is being added into the Netflix, whether that is a movie or a TV show. As you can see, the spike that I've shown you earlier in 2000, from 16 to 20, most of the content that is added into the Netflix is movie data types, movie, and very few are TV shows. Not few, but compared to movie, they are few. There are around 600 movies, 600 shows that is being added into the Netflix in a single year is not a small number. But compared to movies, for 1500, that is a significant difference. And the next chart comes with top 10 content genres on Netflix. As you can see that international movies is in leading with around 2400 change, and next comes dramas with more than 2000. And my next chart comes for the outlier, finding the outliers and the distribution content age of TV show and movies. As you can see, there are a lot of outliers which are being released in the older years and being added into the Netflix in the recent spiked years. And next chart shows my movie duration on Netflix. Most of the movie duration is in between 100 to 110, 120, because as we can see, there are around 1200 movies and 1000 movies for the same range. And my next chart comes for the number of the titles released in a decade. As you can see that I've showed you also the spike in the different years, that 2019 comes in 2010 decade. So the spike is really high compared to 2000s and 2020s. 2020s is not done yet, but there is, in the first few years, we getting 1000 movies is not a small value again. And yeah, next coming to the hypothesis statements. I wanted to show three hypothesis statements. My first hypothesis statement is there is no significant difference between average content age of movie and TV shows added to Netflix. The alternate hypothesis is there is significant difference between the average content of movies and TV shows added to Netflix. And I also got the T static value and P value. I performed two sample test. After performing two sample test, I've got the result. And next hypothesis is content type and content rating are independent of each other. But I wanted to prove that they are interrelated with each other and as associated with each other. For this, I performed chi-square values. After getting chi-square result and p-values, I've gotten that whether they are in relationship or not. My third statement is to prove whether the number of titles added into Netflix are significantly not significant across the years, and that alternate hypothesis proves that they vary significantly across years. For this, I performed an one-way ANOVA test to obtain the results. For feature engineering and pre-processing, as I've told you, this is the second part of my analysis. I've been using data copy, DF copy, for my data analysis. I didn't want to mess up the other algorithms and data analysis. So for feature engineering, I'm using a copy of my data set after altering the results. So as you can see that there are, to handle the missing values, uh, I've used and filled that with unknown values and not available values for whether the unknown results and not available results. And after that, I'm here to find the null values to see whether there is null values or not. As you can see, there are no null values after filling all these values with uh, filling NAs and F filled results. And handling outliers, I have used this is the box plot whether to see which the outliers also, and most of the results are coming from 2012 to 2020 into Netflix. And as you can see that the Q1 and Q3 also, and upper bound and lower bound are also being calculated. After calculating that, I have obtained from 2009 to 2020 as results for the box plot, removing all the outliers. And this is the categorical encoding for my same distribution of content type. Okay, and next, this is distribution of content ratings after, and this is after encoding, and that is before encoding. And coming to uh, textual data pre-processing, there is no need of textual pre-processing for this data because uh, there is no textual columns that need to be done for an analysis section. So we can skip this section. And next comes we can skip this. So I'll just close this. And coming to the feature manipulations, and if we wanted to manipulate or add any features, we can add. As I've added from the date added column, I've separated year added and month added, and also found out the content age as I've told earlier. This is one of the features selection output. Only those columns to be mentioned. And coming to data transformations, I have data transformation my date to time date added column into date time, and also finding the content age of each row. And coming to the data scaling, I wanted to scale using my standard scaler, fitting the transformation and visualizing that. And coming to the data splitting, we can split the data into PC1 and PC2 upon the columns for that are known for features. For the features, I've used release year added, month added, and content age. Okay, after that, I've split the data into 80% training and 20% for testing data. If there are any imbalances in the dataset, there are very few imbalanced datasets, but that does not alter the accuracy, or that does not does not give any precision values for the dataset after imputing after handling the imbalance. So I eliminated the option. And next, in ML model implementation, I've used two ML models. One is logistic regression, and other is uh, this is the cross validation for logistic regression. And second model I use is a random forest. For a random forest also, I've drawn a confusion matrix and evolution matrix and cross validation also. Uh, after determining those two values, I found out that a random forest will be useful for the achieving better overall performances compared to logistic regression. So to conclude, this project demonstrated more analytical approach on my Netflix library for the content between 2016 to 19. Overall, the findings can be informed to content acquisition, production, and marketing strategies to ensure that the subscriber engagement and global expansion can be divided into these genres and age ratings. Thank you.